Hi everyone and welcome to the second week, fourth video of our course From Media Computation to Data Science. In this video we want to synthesize sounds from scratch. You remember that one way to look at sounds were samples. Samples indicate in which way -1 or 1 and how far a membrane swings, for example in our ear or in the microphone in my computer. Let's create random samples. For that, I'll create a variable first, which I call samples, and I want to add random values between -1 and 1 to that variable. So I want to create a list. Let's initialize that list first. So I'm going to set samples to an empty list. Here we go, here it is. Now we want to add values to it. For that, we can use the add block and the pick random number block from the operators category. And I want to add those numbers to my variable. If I input -1 and 1 here and click that multiple times, you see that I only get -1s, 1s and 0s because there are no decimals. I only pick -1, 1 and 0. To also get decimals for our samples, we can just use a little trick. For example, we can just input 0.9999 here. And now if I add more numbers, I will also get decimals. Okay, let's clear the list again and start over. How many samples do we want to add to our list? You might remember from the last time that our initial or default sampling rate is 44,100 Hertz, which means we have 44,100 samples in 1 second of sound. So let's just do the whole thing 44,100 times. If I do it like that, it takes quite a while because we have to repeat it a lot. So let me stop that again and let me wrap the warp block around it. Boop. Here we go, the full 44,100 Hertz or samples at once. And now you can see that sometimes we have positive values. So for example, our first value is 0.179 and sometimes we have negative values. Here, for example, the second value is -0.08. Let's try to listen to those samples. For that, we can just go to the sound category and grab the regular play sound block. We can use the samples reporter as an input, and now let's see what happens. We definitely created the sound, but it's kind of not that pleasant to listen to. This kind of sounds is what you call white noise, so it's a randomly generated full spectrum sound. Can we make a little more beautiful sounds as well? Here comes the second term into the equation. We already heard about frequencies. A frequency is a measure for how often a specific event occurs in a given time unit. So for example, how often the same sample pattern repeats itself in 44,100 Hertz. We can try that by just creating another set of samples, which I'll call samples 2. But those samples too will not be the full 44,100 Hertz, but just a fraction of it. For example, 100 samples. So let's set samples 2 to an empty list again. And let's repeat 100 times. And we want to add those random numbers to our samples 2. Let's try that again. Here we go. Samples 2, but it's just 100 samples long. To now get to the full second again, we want to repeat those same samples, that same sample set over and over again. So we want to add the same samples that we have here in samples 2, a specific number of times. For that, we can use the for each block. And we need to create a third variable, which I'll call sound2. Sound2 is also going to be a list. So I'm going to set sound2 to an empty list. And then what we want to do is we want to add each sample in samples2 to sound2. So I'll grab the add block and I want to add each sample to sound2. If I do that once, like that, I'll get sound2 here, but it's going to be the exact same list with the exact same length. That doesn't really help, so we need to repeat that more often. Let me wrap a repeat block around it. If I repeat it 10 times, I will just get 1000 samples, but I want to get to 44,100, so I'll just repeat it 44,100 times divided by the original sample set that we already have, or the size of the original sample set, which is 100. Let's do it again. Here we go. Oh, forgot the warp block. Let's do that again. Some heavy computation. Now let's go again. Here the 44,100 hertz, so the samples, so the size is the same as in our original sample sound that we had, but we see that our first sample is 0.035 and our 101st sample is that same 0.035 again. So we're repeating the same 100 samples over and over again. Let's try to listen to that one. Just to recall, this was the original sound. And now let's try our new sound, which is sound 2. That's definitely way better. Let's compare it to the play frequency block from Snap. So I'll play the frequency, I have the play frequency block here. What is the frequency of our sound? That's just the number of repeats that we have here. So it's 441 hertz. Let's play that. So that's the 441 hertz that Snap gives us. And now let's play our sound to that. You can hear that the timbre of the sound, so the way the sound sounds, is very different, but it's definitely the same pitch. Can we also change that timbre? Right now we only used random values to create the sounds. What if we would do that in an orderly way? So for example, I could add 50 times -1 and then 50 times 1. I would still have the same 100 samples, or the size of 100 samples, but the sound might sound different. Let's try that. So let me just create another variable, which I call samples3. And I'm going to set samples3 again to an empty list. And we're going to add 50 times -1. Let me just duplicate that from here. And then we're going to do the same thing, but with ones. Okay, now let's take a look at samples3. Here we now have a lot of -1s, and then we have a lot of 1s. Let's now create a sound 3 out of that. So one more variable, sound 3, and let's just duplicate that here, the whole thing. Ooh. And let sound 3 be an empty list in which we add all samples of samples3 to sound 3. Okie dokie, here we go. Bloop. Our sound 3 is here, and it's a lot of -1s, and then a lot of 1s, and then -1s again, and so on and so forth. Let's now play our sound 3. Here we go, there was sound 2 again. And here's sound 3. 2 again. And sound 3. Now you can see that we can also change the way our sound sounds. Again, that term is called timbre, from the way we arrange the samples in the original sample set. Now it's your turn. Create scales, try different frequencies, and write your own songs with your own generated sounds. Have fun, and I'll see you in the next video.